Hi everybody, I'd like to make a video which exposes the biggest scientific oversight that human beings have ever made. When we stopped using Latin as standardized scientific language, science started to fragment, and it's ended up in all the different university departments, and yet they all study the same matter in the same universe. Something's wrong. This video tells you what is wrong and puts it right. We have a flaw, a very basic flaw. We think only in language. So if no human being has ever said it, no human being can even think it. And that's where we are today. I'm going to say it. We need to standardize scientific language. So I'm going to point out the main problems that it causes in classical physics right at the start. The first bit of real physics, Newton and gravity. And yet we still don't have a standardized description of what gravity is. That's a big problem. We must have a standardized description of the Earth as a gravitational body and its field, and the Earth as a magnetic body and its field. That's just common sense. Now you will be able to understand every single word I say today. There is no new science, no new details that you need to know anything about. It's for all of you to wake up. So let's go back to gravity and bring in a standardized definition for universal cause of action. Cause of action for gravity is now said to be the curvature of space-time, but there isn't any. If everybody on the Earth stands up and drops an apple, they go in straight lines towards the centre of gravity. We make models by putting a heavy ball onto a trampoline, which produces a curvature, and then somebody throws a ball. But notice, they don't just release it so it goes in a straight line to the middle. They throw it sideways so it goes round and round. It follows a curved path which is already there. Planets do not do that. There is no curved path in space. So the word curvature is the wrong word. Objects at both sides of the Earth will slide down a density gradient with the direction. And if they're to do that, they must be able to experience that density gradient. And the density gradient must be able to experience the presence of the Earth. So universal cause of action has to be the exchange of information. The Earth and the space outside can exchange information. That's it. Every action in the universe requires a relationship, which requires communication. A definition of communication must be there has to be an exchange of information. Universal cause of action, standardized cause of action. And look what it does. We can go back to gravity and say that gravity is the exchange of information between physical matter and space. It's the simplest exchange of information between matter and space because the magnetic field is more complicated than the gravitational field. It's got two poles. And then there's the Earth as an electrical body and its field, which has three vectors. One centre of gravity, two poles, three vectors. There's a pattern. Electromagnetism, a related pair. Each causes the other, working with a unique partner, gravity. Electromagnetism is now called a fundamental force, another linguistic flaw. Because in classical mechanics, gears and levers and hydraulics, any force requires physical contact. So you can't use the same word for bodies in the solar system where there is no physical contact. Compass needles don't have a force in that sense applied to them. They align with the field. Alignment is different from curvature and force. I can use the same word for all three relationships between matter and space. And now we have started the standardization of language for physics. And we can go on to say the difference between quantum physics and general relativity is that the exchange of information at the large scale is continuous, like a trombone. The exchange of information at the small scale is quantized in exact energy levels, just like a bugle. We can't play any note in between. The electron can go here or here or here, and the exchange of information is quantized and takes place via a boson. Both are exchanges of information, both are correct, and both can now sit down side by side. Quantum physics and general relativity. And do we need to bring the same word general relativity to include magnetic bodies and fields, electrical bodies and fields? That's not for me to say. It's for you to think about. So that rearrangement of physics, we rearrange all of particle physics into related pairs and unique partners, and suddenly it all makes sense. It all fits. So the standardization of scientific language is already well underway and has been drawn out from quantum physics to human behavior. It's here. So wake up. It's coming. Bye for now.